1.12, transformations of functions, and Connell's going to be our first reader.
An important aspect of understanding functions is the concept of transformations. Throughout this course, as well as past and future courses, we will study a variety of functions and their graphs. All of these functions can be viewed through the perspective of transformations. Transformations will weave through everything we learn in AP Pre-Calc, and they provide a way for us to connect to topics we learn throughout this course. Below is a table of transformations along with how each transformation affects a graph.
All right, fantastic. So we have a vertical translation, and so a translation is more of a shift. That's what I'm going to call it. It's going to be more of a shift. So a translation, when it happens outside, is going to do it vertical. And it's going to do exactly the way you think it does. So if I have f of x minus 2, guess what happened to my graph? It shifted what? Down 2. All right, and a horizontal translation happens inside, okay? So it messes with the x, and it kind of does the opposite of what you think. So for instance, if I have f of x plus 2, guess which way it moves? It moves left, all right? And then this is probably where you're comfortable, all right? So last year in Algebra 2, this is probably where you guys stopped, all right? This is where we're going to focus some time on it as well. And so we're going to talk about vertical dilations and horizontal dilations. A vertical dilation is outside, okay? So just like our vertical translation, our vertical dilation is outside of my function. And it's going to do exactly what you think it does. So if I have to multiply by 2, it's going to vertically dilate or stretch by 2. However, this negative thing changes the y, which reflects over the x-axis, all right? A horizontal dilation is inside, all right? So it messes with the x. And a horizontal dilation is the reciprocal of that number. So if we start out with 2, if we start out with 2x, it's a dilation horizontally of what? What's the reciprocal of 2? 1/2. All right, and so it'd be a horizontal dilation of 1/2 there. It does the opposite of what you think again. And again, if I have a negative on my inside, it changes the x, which means it reflects over the y. All right, and I think Mr. Passwater did a fantastic job on these little notes, tips, and tricks. All right, so Connell, pick a reader.
Sure.
A few important notes and tips on transformation. Any transformations that affect the x values will occur inside parentheses with the x variable. Any transformations that affect the x values will do the opposite of what it looks like to the x values.
All right, fantastic. So if we're talking about x, we're talking about the horizontal movement. And so if it's inside, just like this, it's going to do the opposite. It's going to shift the opposite way, and it's going to dilate in the reciprocal way, okay? It kind of does the opposite of what you might think, all right? That's why they're the x's. If the x's did the opposite, that's why you broke up, okay? That's the way you can think of it. All right, here we go. And then number 3 and 4.
Any transformations that affect the y values will occur outside the parentheses. Any transformations that affect the y values will do exactly what it looks like to the y value.
All right, so again, outside of your function, it does exactly what you think, and it will shift the y. All right, so this is a shift up or down, and then this is a dilation vertically up and down. All right, because it's outside. All right, let's put it together. Here we go. Pick a reader.
Jackson.
Let g be a function of is a transformation of the function f such that g of x equals 2f and c g minus 3 and c, or x minus 3 plus 1. Describe the transformation of the function f that results with a function g.
All right, fantastic. So let's talk about what this 2 does. All right, what does this 2 do? It dilates. How does it dilate? It vertically dilates. All right, it vertically dilates by what? By 2. Perfect. A vertical dilation of 2. All right, and then what does this x minus 3 do? Okay, right 3, but we're going to call it something else. It does go right 3. I love that. However, that's kind of the slang term. So this is a horizontal what? Translation. All right, and I'm doing this because it's not going to say right 3 on an AP exam. So this is a horizontal translation of what? Of 3. Now, we should know that that means to the right 3. Okay, and then what does this plus 1 do? It goes up 3, but what are we going to call that?
Translation.
A vertical translation, exactly. So it's a vertical translation of what?
1.
Of 1. All right, pretty good? Cool. All right, before I move on this part, I want to talk about running. Does anybody run cross country or anything like that? Or soccer or basketball or anything like that? All right, so before you run, you should do what? You should stretch. And so that's exactly the way you should deal with your movements. And so the stretches are your dilations, and then your runs are kind of like the translations. All right? And so if you can always think of you should stretch before you run thing, that's the same way it works with mathematics too. Okay? And so I think that's the easiest way to think of it. All right? I am not a runner, nor do I want to be, because those people are crazy, because nothing's chasing you and you're running 5 miles or something more, and that's crazy. All right. So here we go. All right, example 2. Pick somebody, Jackson. Let n be a function that is a transformation for the function m, such that n of x equals -4m, parentheses 2x, parentheses. Describe the transformations of the function m that result with the function n. All right, beautiful. So I'm going to work with this 2x first. Okay, that's going to be a stretch or a translation. Is that going to be a dilation or a translation?
Dilation.
It's a dilation, all right? And it's my x, so it does the opposite of what you may think. And so this is a what kind of dilation?
Horizontal.
A horizontal dilation of what?
2.
It's not 2. It's 1/2. Why is it 1/2?
It's the opposite.
It's the reciprocal of it. It's the opposite of what you might think. Now, I'm going to break this up into 2 things. And so what does this 4 on the outside do?
Dilate.
What kind of dilation? A vertical dilation of what?
-4.
Not -4. I'm going to deal with the negative in a sec. So this is a vertical dilation of 4. Now, let's talk about the negative. So what does the negative do? It reflects how? It reflects over the x, exactly. All right, so it changed its y, so it reflects over the x-axis. All right, example 3 now. Pick a reader. Sigma.
The graph of y equals f of x consisting of 2 line segments and a semicircle is shown for -3 less than or equal to x less than or equal to 5. Sketch a graph of g on the same axes of both, where g of x equals f parentheses x plus 3 and parentheses -4.
Love it. All right, so let's talk about what's happening here. What's talking about the shifts or the stretches. So what's happening with this x plus 3 thing? What? It goes left how much? 3. And what's that -4 do? Goes down what? 4. All right. And so I want to do an ordered pair method with you. I know that this one's very basic, but I'm really leading you on to the next example. So, because do I have any stretches on these? No. And so this one's just like a straight up shift. It's going to shift left 3 and down 4. Like this one's pretty easy. However, I want to do this one with you. And so I'm going to say x sub f, okay? I'm going to take whatever x value I have of my function f, and what am I going to do with my x's? I'm going to shift it what? Left 3. So I'm going to subtract 3 from every x value. Okay? And then what am I doing with every y value? I'm subtracting how much? 4. And so this is what I call the ordered pair method. And I think you'll see how it works now. And so if I look at this ordered pair right here, I'm going to shift it left 3 and down 4. However, what is my ordered pair on this one? -3, comma 3. So if I substitute in -3 here, what do I get? -6. And if I substitute in 3 here, what do I get? -1. So now my new ordered pair is -6, -1. All right? All right. So now let's do it again. So then what's this ordered pair right here? 0, 1. So what's my x value of my new one? -3. What's my y value? negative 3. And so now I go negative 3, and then there we go. Now, this one's pretty easy because did I shift down and then, or did I shift left and then down? Yeah, I shifted left and then down. Like this one we can do real simple without the ordered pair method. However, I'm teaching it you for the next example. All right, so let's do it again. So if I substitute in this part right here, all right, so what's that part right there? 3 comma 1. And so now what would it translate to? 0 comma negative 3. And so I'd have 0 comma negative 3. Now, does this arc go up or does it go down? What is this semicircle doing? It's going up still because there's no reflection that happened. It is still going up, and that was terrible. And so we're going to go like that. And so then let's do the last part. And so what's this ordered pair? 5, 1. And so when I substitute it in, what do we get? 2 and then negative 3. And so I have 2, negative 3, and it finishes up right there. All right? All right, now let's look at example 4. All right? So the graph of h of x has a hole at x equals 4 and consists of 3 linear line segments. Sketch the graph of k so that k equals negative h of 2x plus 1. Now, what's going on here? Let's just talk about orally real quick. What's that negative do? It reflects over the x. All right, what does this 2x do? A horizontal dilation. All right, of what? Of 1/2. It's the reciprocal. And then what does this 1 do? It goes up 1. So I'm doing 3 things, and it's just not just a pure movement, left, up, down, right thing. It's going to be a scrunch, basically. Okay, so like a shrink of 1/2 and a flip and up 1. All right, and that's why I go with the ordered pair method to kind of make sense of everything. All right, so let's deal with what's happening to my x's. So inside is what's happening with the x's, right? And so x sub h, what is happening to my x sub h? What's happening to my x's? It dilates by what? 1/2. So I'm going to say 1/2 x sub h, all right, because I'm going to half every x that I have. Then what's happening to my y's? 2 things are happening to my y's. Let's deal with my stretch first, okay, my dilation first. So that negative thing is going to do what? It's going to reflect over the x, so it's going to change my y to a negative y. And then what's this 1 do? It goes up 1. And so now by the ordered pair method, I can just substitute in any ordered pair and I can get my new transformed ordered pair right there. All right, so let's play. So now, what's my ordered pair on this one? Negative 4, negative 3. And so when I substitute in negative 4 here, what's my new x value? Negative 2. And then when I substitute in negative 3 right there, what do I get here? Positive 3 and then plus 1, which is 4. And so now I'd have negative 2 comma what? 4. So I went from right here to right there after my transformation. All right, let's do it again. So what's this ordered pair right here? Negative 2, 1. So when I substitute in negative 2, what do I get for my new x value? Negative 1. Then if I substitute in 1 right here, what do we get? 0. All right, and so now I'm right there. All right, and so if you look just at this linear segment right here, that scrunched by 1/2. All right, so horizontally dilated by 1/2. It reflected and moved up 1 to give me right here. All right, so now let's do this one. So what's that one? 0, negative 2. And so what's my new x value? Still 0. And then if I substitute in negative 2, what do we get here? We get 3. And so now I transformed to right there. All right. And so now let's do it again. So now let's go with the hole. And so what's my hole? 4, 2. So now what's my new x value? 2. And then what's my new y value? Negative 1. And so now I have a hole at 2 comma negative 1. And then let's finish it up right over here. And so what is this one right here? 6, 4. And so then what's my new x value? 3. And then what's my new y value? Negative 3. So now I have 3 comma negative 3. And there we go. All right. The only thing we've left off is this little dot right here. So what's this dot right here? 4, negative 1. And so then when I substitute it in, we end up with 2 and 2. So I have 2, 2. And so I'd have a dot that fills in right there. All right. Do you see how much easier that is doing the ordered pair method than like trying to scrunch it, shrink it, flip it, move it up? Like that would be crazy without that method in my opinion. All right. Let's keep moving. Here we go. Example 5. Who was our last reader?
The domain of f from example 3 is negative 3 is less than or equal to x, which is less than or equal to 5, and the range of f is 1, which is less than or equal to y, less than or equal to 3. Find the domain and range of g, where g of x is equal to 2f times x plus 3 minus 4.
All right, love it. All right, so I again try to do the ordered pair method on this one. All right, so let's deal with the x's first. So what's happening to x sub f? What's happening to it? This x plus 3, what's happening to it? It's moving left. So how much is it moving left? 3. So I take any x value and what do? I subtract 3 to it. All right, and then let's talk about what's happening to my y's. What does that 2 make it do? Dilates by how much? 2. And so now I have 2 y sub f, and then what? What's that negative 4 do? Brings it down 4. All right, and so there's my ordered pair. All right, and so now I need to find the domain. Domain consists of what values? The x's, okay? And so now I'm going to do my end caps, basically. So I'm going to substitute in negative 3 in for my x. So what do we get? Negative 6. So now my domain goes from negative 6 all the way till what? Now I'm going to substitute in 5. And so what do we get now? 2. So I go, my domain now is negative 6 to 2. All right?
Where did we get negative 6 from?
When we substituted in our negative 3
Negative 3 where?
in for x's. All right. All right. So now we're going to do our range. All right. So our range, what are we going to substitute in? The y's. Do we substitute in the x part or the y part? The y part. Okay. So now we're going to substitute in what? 1. And so when I substitute in 1, what do we get? Negative 2. So now my range goes from negative 2. And then I'm going to substitute in what? 3. So now I substitute in 3 and I get what? 2. So now my new range is negative 2 to 2. All right? All right, example 6. So I have this table of values. I love these, by the way. And so h of x is given to us as 3p of 2x minus 1. And we need to find the following values. So are we going to plug in or substitute these values in? We're going to substitute these values in because we're going to replace the x. All right, here we go. So we're going to find h of negative 1. So when I substitute in negative 1 here, I'd have 2 times negative 1. What's 2 times negative 1? Negative 2. So now I'm finding p of what? Negative 2. So now I need to look at my little table. What's p of negative 2? 1. So now I have 3 times 1, which is how much? 3. 3 minus 1 is 2. So now I have h of negative 1 is 2. All right, let's do it again. So now I'm going to substitute in what? 2. So when I substitute in 2 now, what do I have? P of 4. P of 4 is 3. So now I have what? 3 times 3, which is 9. 9 minus 1, which is 8. Pretty simple. All right, so we're going to do it again. So now we're going to find h of 0. So when I find h of 0, I really find p of what? 0. So p of 0 is negative 1. And so now I have 3 times negative 1, which is negative 3 minus 1, which is negative 4. Love it. All right. All right.
The function g is constructed by applying 3 transformations to the graph of f find the values of A, B, and C.
All right, so how do we do a horizontal dilation factor of 3? Which one does that deal with? A, B, or C? A horizontal dilation. Is that going to deal with A, B, or C? B. All right, so what does B equal? It's 1/3 because it's like the opposite of what you think because it's the reciprocal of it. It dealt with the x's. That's why they're the x's. All right, and then it says a vertical dilation of 4. So which one is the vertical dilation? A, B, or C? A. And so it's the y, so it does exactly what you think. So what's A? 4. All right, and then the vertical translation. So what does the vertical translation deal with? C. And so C equals what? -7. Now, what did that really do? It went down how much? 7. All right. All right. Example 8 now. Kefa, pick a reader.
The table above gives values for function h at selected values of x. Let k of x equals times bx plus c, where a, b, and c are positive constants. In the xy plane, the graph of k is constructed by applying 3 transformations to the graph of h in this order. A horizontal dilation by a factor of 1/2, a vertical dilation by a factor of 3, and a vertical translation by 1 unit. Find the value of k of -6.
All right. So I'm not going to find k of -6 yet. I personally want to build k of x first. All right. And so we're going to basically do what we did on the last one, except now we're going to use it. So let's build k of x. So a horizontal dilation by 1/2. Is that inside or outside of my function? Which one is that giving me? Is it going to give me A, B, or C? It's going to give me B. Well, what is B? 2. All right. And so now I have h of 2x. And so now it says I'm finding a vertical dilation by a factor of 3. Does that give me A, B, or C? A. It gives me A. And so what is A? 3. All right. And then a vertical translation. Sigma, what does that one give me?
C.
C. I agree. And so what would be C? +1. All right. And so now that I have k of x, now I can substitute in anything that they want me to. All right. And so now I'm going to substitute in what? -6. So now we're going to substitute in -6. So I'm really finding h of -12. Robert, what's h of -12? 1. And so now I have 3 times 1, which is 3. 3 plus 1 is 4. All right, so k of -6 is 4. All right, pretty good? Cool. All right, one more reading.
The function p is given by p of x equals 3x minus 2. The graph of r is the image of the graph of p after a horizontal translation of 4 to the graph of p. If r equals ax plus b, find the values of a and b.
All right, what in the world did that say? I don't know. Let's break it down. So R is the image of the graph of P after a horizontal translation of 4. Well, how do you get a horizontal translation of 4? What happens there? Is that inside or outside? It's inside, right? And so what's inside? X minus 4. So eventually I'm going to have x minus 4. And so R is the image after P had that horizontal movement. And so R of x is equal to P of x minus 4. Okay? Because it horizontally translated 4. All right? And so P of x is already this 3x minus 2. So instead of x, guess what I'm going to replace x with? X minus 4. All right? And so now we end up with 3 times the quantity of x minus 4 and then minus 2. And so I need to get it in this form because it told me to. So what do we need to do with this 3? Distribute it. So we're going to distribute that. And so now I end up with 3x and then minus, 12 and then minus 2. So we're going to get 3x minus 14. All right, that's fine. We can skip steps. That's fine. All right, and so then I'm finally asked the question, find the values of a and b. And so what does a equal? 3. And so what does B equal?
Negative.
Negative 14. Now, on the AP assessment, they might be like, what's A plus B? And then you'd say what?
Negative 11.
Negative 11. So that's the way they could do a multiple choice question. All right.